A very good afternoon to India and good morning to Uganda. On behalf of Mechanical Engineering Department, Medicaps University Indore, I, Ram Bansal, welcomes you all in international webinar, Sustainable Development, Manufacturing and Machining. First of all, I am Professor Dr. D.K. Patnaik, the Pro Vice Chancellor, Professor Dr. D.K. Panda, all the deans, heads of the departments, faculty members, students, and their participants. At this juncture, I am pleased to introduce Medicaps University as the topmost private university in the state of Madhya Pradesh, India, as per NIRF ranking issued by central government MHRD in 2017, and also ranked top in the private institute in central India according to the I3RC Times Engineering Survey 2019 and 2020. Since its inception in July 2000, Medicaps has inconsistently aimed at creating an ideal ambience for budding technocrats and managers, helping them to grow like a true professional with the aim of spreading wings and move out for more exposures and winding of the periphery. The foundation of Medicaps University has been laid down in 2015. The university is maintaining the objectives of imparting best quality education. Medicaps is offering UG, PG and PhD programs in engineering, management, science, pharmacy, agriculture, computer application and commerce. Our academic curriculum is prepared to enable the students to face the challenges in industry with application of knowledge gained during the program of study. To achieve this, it is important that the students are exposed to ongoing research, latest technology development and industry practices in their particular domain. As we all are here to attend webinar on sustainable development, manufacturing and machining, we have with us today the speaker, Dr. Milan Sevlan Denishan. I request to Dr. Ravin Pathak for introducing our guest and welcome him.
Thank you very much, Ram Bansal sir. And now I am on the behalf of the Medicaps University. I welcome Dr. Milian Selvam. Milian sir, I am audible. Milian sir.
Yes, Professor, you're audible.
Yeah, thank you, sir. So, welcome, sir. Milian Selvam is working as a senior lecturer and a research coordinator in the Department of Mechanical Engineering, Kampala International University, Uganda. He received his BTech degree in Mechanical Engineering from Bharat University, Chennai in 2007 and ME in Manufacturing Engineering from Anna University in 2009. He completed his research in the field of metal cutting tool and his area of research interest including metal cutting fluids and manufacturing optimization. So that is our great pleasure that you are here for us. Thank you very much, sir. So now the stage is yours. Please, sir.
Thank you, Doctor. So, warm greetings to the chairperson, the Professor Ram Bansal, and the organizer of this webinar, Dr. Ravin.
Sir, if possible, can you open the camera, sir? We can see you.
Sorry, there is some problems.
Okay, no problem. That is my request only, sir.
Okay. So,
Milian sir, your mic is muted.
So, can you hear me? Can you all hear me?
Yes, sir. Please.
Okay. So, this is Dr. Milan. I am here to share something about sustainable development, manufacturing, and machining. So, I believe this webinar may give answers for the following questions. That is, why focus on sustainability? Why sustainable manufacturing? Why sustainability in manufacturing? and sustainable manufacturing in real-time practice. So we pray to the Lord Almighty and let's start the session. So my presentation outline is, I classify my presentation of this session into 3 parts. That is, the first part is all about sustainable development, sustainability, and sustainability in manufacturing. And the second part is about sustainable machining. And the third part is some project ideas for students. So let me start with sustainable development. In September 2015, the United Nations made a historical release on the Sustainable Development Agenda, named as Sustainable Development Goals. In short, SDG, Sustainable Development Goals. So there are about 17 goals that should be practiced by all the United Nations, that is members of all the United Nations, even the universe. That is, first one is end poverty in all forms everywhere. There should not be any poverty in everywhere in the universe. And the second one, end hunger and improve nutrition for every humans. And the third one, ensure healthy life and quality medicine for all age groups of humans. And the fourth one, improve the quality of education and to provide lifelong education for everyone. That is to impart more on research, to concentrate on more on research along with academics. I say, my professor usually says, that is, research and academics are the 2 eyes of an academician. So, with 2 eyes, we have to see the community or the society. So that is a nice. That is, I say that as a proverb given by my professor. And let's continue. The fifth one is gender equality. Achieve gender equality and empower women and girls. That's a very important point. And the sixth one is clean water and sanitation. That is, ensuring the availability of clean water for everyone. And the seventh one is affordable, reliable, and sustainable energy for everyone. So, and the eighth one is a decent job and a sustainable economic growth for all families. And the ninth one, build resilient infrastructure and promote inclusive and sustainable infrastructure and also faster innovations. And the 10th one, reduce inequalities within and among countries. And the 11th one, safe and affordable housing for everyone, affordable and sustainable transport systems also for everyone. So inclusive and sustainable urbanization. And the 12th one, implement the 10-year sustainable consumption and production framework. And the 13th one is much alarming goal, that is the climatic action. So the climate change in real world, in real practice, I'm saying the climate change is real. Even we are experiencing the climate change That is, before 2 decades, for students, it is maybe before 1 decade, the climate is different. That is the annual rainfall and the summer, the hotness, and the winter chillness. I hope you are not experiencing that type of climate in maybe in 2020 or 2021. That is climate changing action. So the best example is our capital, New Delhi. So this is a very alarming one, and I will show some data at the end of this presentation. So the 14th one is consume and sustainable use of aqua resources, our aqua resources. And 15th one, protect the ecosystem on land. 16th one, provide peace and justice for everyone. 17th one, strengthen the global partnerships. So sustainable development. So where it arises. So what that is the who proposed this sustainable development. That is Dr. Brundtland. She is named as the mother of sustainable development philosophy, and she is a professor and a researcher from Norway. So she that is defined sustainable development as development that meets the needs of present without compromising the ability of future generation to meet our own needs. Okay, so we should not overconsume Earth's resources, our minerals, that is the fresh water, whatever we have, and the other natural minerals, that is sand and other minerals, by mining resources, all the mining resources. So that's a definition. And according to United States Environmental Protection Act, so it is a regulatory body. So they are defining sustainable development as cost effectively producing goods with minimal environmental degradation. That is the point. The future engineers should concentrate in this minimal environmental degradation while conserving energy and our natural resources, which in turn enhances the product safety, thereby increasing its global competitiveness. So most of the European Union countries are moving towards, even US, moving towards this minimal degradation, minimal environmental degradation manufacturing process. So according to Donfeld, sustainability means activities whose environmental impact is below the level of and the self-recovery capability of the natural environment. So, and sustainability. See, in every nations and in all the sectors, for an example, automobile sector, textile sector, medical sector, aerospace, and these are the major manufacturing sectors. In all the sectors, manufacturing is an inevitable process. And now, many countries, as I mentioned, in many countries are showing interest towards eco-friendly manufacturing process by providing eco-awareness regulations to prevent their environment from further damaging. So here, the key word is eco-friendly. we have to critically think about this word eco-friendly. In simple understanding for the students, I'm saying in simple understanding, the ecosystem comprises of all types of plants, animals, minerals, and uh, humans. We are that is sixth sense animal and the humans, and we are one element that our routine lifestyle, that is our humans, our routine lifestyle should not disturb this ecosystem that is eco-friendly, and the manufacturing process associated with that is eco-friendly manufacturing system. Hope you all understood about eco-friendly manufacturing system. This eco-friendly manufacturing system is otherwise known as sustainable manufacturing. That is our topic. This eco-friendly manufacturing is otherwise known as sustainable manufacturing, and it is also known as green manufacturing. So I hope you got an students got an idea about sustainable manufacturing, about our topic, and let me continue with the sustainability. So there are 7 elements in sustainability, that is remanufacture, redesign, recover, reuse, recycle, reduce. And the domains of sustainable manufacturing, are that is economical aspects, environmental aspects, scientific aspects, and manufacturing practices. So I will explain this sustainability elements maybe in the next slide by giving a case study. Why we have to focus on sustainability? Here I have presented some data, that is, in last 5 decades, humans have consumed more resources than in all previous history. That is due to the scientific development. In total, 60 billion tons of resources are extracted annually, which is 50% more than the last 3 decades. So as much as fresh water is consumed in the last 30 years, that is, let me explain in terms of manufacturing. See, for producing a car, a automobile, a car, at an average, we are consuming 1,48,000 liters of fresh water, not hard water. It is fresh water. We are consuming fresh water. 1,48,000 liters of fresh water. So just imagine how big it is. So how many cars are manufactured in our nation? How many cars are manufacturing daily? How many plants we have? Right? So one thing, whether car is essential, yes, it is essential. It is a need. In 2020, without automobiles, there is no transportation. But we can think about reusing or recycling effectively. Even we are reusing, our manufacturers are reusing and recycling the water, but we can increase the effectiveness of using water with least wastage, right? And the second one, we can think about alternate to petroleum fuels. We can think about e-vehicles, right? So that is emerging in India now, and all over in most of the Asian and other countries also, right? And also I want to register here, according to a recent report, that universal human population is nearing 800 crores. 800 crores. That is 8 billions. It is very big, and this made us to consume more natural resources, right? So it's a time to think about sustainability for our future and our future generations, right? See, why focus on sustainability, right? So this is a plot, it's a general plot versus how do we achieve this, and rate of consumption of resources. See, the upper line refers the consumption rate of the current consumption rate, and just see the sustainable rate. So what we have to do? We have to reduce, reuse, recycle, and remanufacture the things, right? So the wastage in sustainability, the wastage should be minimal. So why sustainable manufacturing, right? As I explained, so manufacturing, we know that is making a raw material to a final shape or a final product, modifying its geometry, modifying its mechanical, physical, and chemical properties is manufacturing, getting a final product. For an example, a metal or a metal alloy to final engine parts, piston, cylinder, and cylinder block, piston rings, connecting rods, shafts. If that is manufacturing. So what is sustainable manufacturing? Even it is same, making a product to making a raw material to a final product with conserving energy, with the points like conserving energy, non-polluting, and using minimal natural resources. That should be safe to employees, that is operators, communities, and consumers. So why sustainable manufacturing? Sustainable manufacturing is a process which generates minimum quantity of waste, leading to zero waste, demonstrating improved environmental performance and energy efficiency while providing operational safety and personal health. Sustainable manufacturing is a branch of sustainability that deals with economical, environmental, social objectives of manufacturing activities. See, so here I have presented a data. See, manufacturing is the most resource intensive process for all human activities. So according to Niti Aayog, Niti Aayog is the agency for sustainable development that is operated or regulated by Prime Minister's Office, Niti Aayog. Report, Manufacturing India 2025. Manufacturing India 2025. The manufacturing share of GDP, that is gross domestic product, in India is planned to rise from 16% in 2016, and the target is 25% by 2025. So we are almost we are doubling the manufacturing in all the sectors. See, just think how much resources we need, and whether we are that is the point, is whether we are going to follow the traditional manufacturing process or sustainable manufacturing. That is the point. So the challenges towards sustainability are global warming rises due to carbon dioxide emissions, contamination that occurs in air and water, population explosion, as I mentioned, and improper waste management. There is a point, improper waste management, that is a emerging research area. There are plenty of projects are there. Over exploitation of natural resources, and the final point. And some popular words about sustainable manufacturing, as I explained. So green manufacturing, clean manufacturing, environmentally conscious, environmentally responsible, eco-friendly manufacturing. And sustainable manufacturing in real-time practice. How we are going to practice a flow chart or a graphical representation for this. That is using renewable materials that don't deplete the natural environment. Okay. So just remember this point, renewable materials that don't deplete the natural environment. Okay, I will explain this point in sustainable machining part. So using fewer materials and inputs, materials that are non-hazardous and are recycled. Modifying production process to use less energy, water, and materials, and to produce less waste. Using less packaging, lowering product weight, using more efficient transportation and logistics. Working with stakeholders like customers and retailers to reduce the environmental impact of sales and distribution. So expanding the life of product, making it easier to repair or designing it to use fewer resources during use. Designing your product to be reusable, remanufacturable, recyclable, or biodegradable. So this is the data collected for our nation. That is, this is the number of deaths due to air pollution, right? So just you can see year by year, the number of deaths due to air pollution is increasing. This is the after effect of air pollution. People dies due to various diseases like asthma and lung cancer, etc., etc. So this data may be annoying you, and almost in 2019, around 16 lakhs of people have sacrificed their life due to air pollution, right? So this is the alarming one, and some recommendations. That is, this is from my paper, published in my paper. So I am so giving some recommendation to all the territory governments. That is, strict actions against the violators, right? Violators, creating awareness among people on the downside of environmental pollution through social medias. So everyone are holding now, all are having their own smart mobiles now. Irrespective of urban and village, everyone are using that is smart mobiles. We can make some that is network social media awareness regarding this pollution, and planting more trees, and strict action against burning plastics and polymers, and creating awareness not to burn plastics and polymers, awareness of using bicycles, electric vehicle for short transportation. So electric vehicle is a eco-friendly vehicle, and most of the manufacturers are concentrating in producing this electric e-vehicles, that is e-bikes and e-cars. That is the largest manufacturer. Tata is releasing its e-vehicle, has released its e-vehicle, and many that is e-bikes are there. That is including Bajaj, and so many manufacturers are creating its e-bikes. The after effects of e-vehicle is environmental friendly, but there is an after effect, that is e-waste management, that we will talk later. That is on one thing we have to focus, e-waste management. So electric power, that is creating renewable electric power. Okay, so creating air pollution awareness in school curriculum itself. So many regulatory bodies are there all over the world. That is notable one is notable regulatory bodies are European Environmental Agency (EEA) and EPA, UNEP, GAHP, and even our nation have regulatory bodies such as National Green Tribunal Act, Environmental Protection Act, uh, Water Air Prevention and Control of Pollution Act, and even more. So the next part is about sustainable machining. So what is metal cutting fluids, and what is the need of that? See, so in machining process, the operator operates the machine. That is, the simple one is the basic machining operation is the lathe operation. So the mechanical engineers, maybe the second year students from second year, you are practicing the machining operation or machining practices. That is, the basic one is lathe, turning, chamfering operations, threading operations, boring operations, many operations we can do in lathe. There you may observe some white color, white liquid falling in the, that is, tool work interface area. That white color liquid, that is the cutting fluid, right? So there are so many types of cutting fluids. The white color in appearance shows it is emulsified cutting fluid. So what is the need of a cutting fluid, metal cutting fluid? What is the need? That is, the first one, it will cool the cutting, that is the cutting tool and workpiece. So when two metals collide or rub each other, large amount of heat will generate. That heat is a harm to the cutting tool and even the workpiece surface. So there, the heat is generated due to friction. So to cool the that is interface, that is tool work interface region, and to lubricate the region, we are going for this cutting fluid application. So there are so many types of cutting fluids. The general most common cutting fluid is emulsified cutting fluid. Around 80% of manufacturers and the laboratory works, we are using emulsified cutting fluid because of it is cost effective, and there are neat cutting fluids, that is synthetic mineral based cutting fluids are there. It is little expensive, right? So auxiliary functions such as, that is the functions of cutting fluid, such as chip removal, rust inhibition, etc., enhance the machine quality by reducing the cost of machining. So it will reduce the power consumption and reworking, scrap cost, etc. So air quality issues with cutting fluids. So the cutting fluids are highly vulnerable to microbial contamination. Mist and vapor generated are harmful to the operator. It creates lung disease. Direct exposure leads to skin disease to the operator. respiratory-based diseases to the machine tool operator. That is the first point, highly vulnerable to microbial contamination. That see, cutting fluids will be reused, will be stored in tanks constructed at the bottom of the machine, and it is reused continuously for machining operation, maybe for 15 days or 20 days. That's depend upon the manufacturer. So prolonged storage of cutting fluid creates microbial contamination, and that is, even it is vulnerable to fungus. So that microbial contamination and fungus is not good for the operator. So when it is those contaminants, when it is exposed to human skin, it creates serious issues, very serious issues, like skin cancer is the main one. So metal cutting fluids, see, cutting fluid consumption is estimated as more than 100 million gallons per year in US. 100 million gallons. It is very, very big. That is in United States. And you just think for our nation and other Asian countries, highly manufacturing Asian countries like China, our nation, we are consuming many, very big. The total there is a total cost of purchasing and disposal is more than $48 billion as per US report. And another report says cutting fluid cost is it contributes 7 to 17% of total manufacturing cost in German automobile company. Disposal and recirculation forms a major share of cost. This cost of cutting fluid. So what is sustainable machining? See, sustainable machining is towards dry cutting, but dry cutting has some that is serious problems like high generation of heat that may harm the cutting tool and the workpiece surface. So producing, that is machining, high quality product is desirable, but in dry cutting it is impossible due to the generation of heat. So what we have to do? See, currently we are using petroleum-based metal cutting fluids, synthetic, semi-synthetic oils, right? And even emulsified oils. There are many mineral-based oils. Even our corporations, that is IOC, BPC, that is IOC, Indian Oil Corporation, is producing the machining cutting fluids. They are having different grades. And what is towards sustainable? So towards sustainable, petroleum-based cutting fluids is not sustainable. That is it's a natural resource. It's a resource. And what is sustainable is towards minimum quantity lubrication. To use very minimum quantity of lubrication of cutting fluid, okay, to the cutting zone. See, what is minimum quantity lubrication? You have to understand what is the current. The current cutting fluid supply is flooded lubricant. See, you can see a flexible pipe on every machine tools. That is, the cutting fluid is supplied or pumped to the cutting interface via that hose, that is the flexible hose, as flooded. as flooded. See, liters of cutting fluids will be consumed. Even we are reusing that, but uh, by practice we are consuming that on the we are pumping that to the interface. So what is minimum quantity lubrication? See, minimum quantity lubrication is using very minimal amount of cutting fluid. Maybe it is mineral based or vegetable based, along with compressed air. See, the natural air, right? Natural air, we can use the natural air, right? In compressed mode. So pressurized air hits on the interface. So the air does the job of cooling, and the minimum amount of lubricant or oil present in the air will lubricate the cutting, that is cutting zone, that is tool work interface zone. So both the cooling that is objective and lubricating objective will be achieved in minimum quantity lubrication. So in the past decade, it is a trending research area in machining, that is towards sustainable machining solution. So I said petroleum based is not sustainable machining or sustainable manufacturing. So what is next for sustainable manufacturing is using vegetable oil based metal cutting. So vegetable oil, the oil extracted from maybe mustard, coconut, or groundnut. So what I said is edible oils. What we are consuming, mustard or coconut or groundnut, all are edible oils. What we are consuming, we can think for some non-edible oils, even cottonseed. Cottonseed mostly we are not consuming as edible, right? In few places they are consuming, right? But it is very minimum. And neem oil, castor oil. These are non-consumer, non-edible oils, and we can think about we can use those oils for producing vegetable-based cutting fluids, and for producing, that is quality-based cutting fluids, some nanoparticles may be incorporated with the metal cutting fluids, metal working fluids, right? Right. For producing better machined surface. Right. So that is sustainable metal cutting solutions. So future engineers should think on this while going for machining. Should think of this, right? So what is MQL versus pleasure lubrication? See, as I explained, in MQL, that is minimum quantity lubrication, the flow rate is very minimum, that is 50 ml to 500 ml per hour. Even it is lesser. Even we are practicing in current practice, it is at much minimum as 20 ml per hour. 20 ml of lubricant or coolant per hour. You just imagine 20 ml is very less, very less. So the advantages are reduced tool wear, reduced surface roughness. Even for that is in traditional machining, traditional flatted machining. Just imagine the flow rate is 120 liters per hour. You just compare it with the MQL. It is very big, very big, right? So using vegetable-based cutting, that is cutting oils, there are so many advantages. That is high biodegradability. It does not harm the nature, and we are not consuming the natural resources, right? Low pollution to the environment, and compatibility with additives. Additives means oxidative additive, antifungal additive, and antimicrobial additives, those are chemicals, and low production cost. It will reduce the production cost when compared to mineral based. Wide production possibilities, low toxicity, high flash points, high viscosity, right? And some disadvantages are oxidative stability, and we can overcome this oxidative stability or making vegetable oil based emulsified cutting fluid. It will be having more oxidative stability, high freezing points, right? Yeah, so right, even there is anti-freezing agents are there, right? That depends upon the climate, right? So practicing vegetable-based cutting fluid in Kashmir, I hope it is not possible because the temperature there, the absolute temperature there is much lesser. It will create some freezing, but anti-freezing agents are there, chemicals. So poor corrosion protection, right? So that depends upon the vegetable oil, right? Even there is corrosion protection vegetable oils are there. Some research opportunities in metal cutting fluids, development of new vegetable oil cutting fluids, right? MQL using vegetable cutting fluid along with the nanoparticles. So the new thing is, so aligning with Industry 4.0 standards. So artificial intelligence coupled with this automation, which enhances the productivity, is the current trend, right? Current trend. So maybe if there is some master students, you can think about it. So artificial intelligence coupled with manufacturing, artificial intelligence coupled with machining, right? So so artificial intelligence is the future. I say it is the future of engineering, all engineering, and some project opportunities for engineering students. So sustainable project opportunities, that is solar water pumping for irrigation, right? So you can make some cost-effective solar water pumping irrigation for irrigation purpose, right? That is regenerating our resources, that is solar resource. So design of renewable energy based some solar related projects, magnetic refrigeration, wind driven charging of batteries, implementation of solar energy in eco cities, and very many. These are few. And these are some publications, my publications in sustainable machining, some notable publications. And final thing, my concluding remark, remark is, all innovations borns from needs, right? So we have to look for the needs. What is the need and what is existing and what improvement we can see that is towards sustainability, right? So thank you all for listening, and if you have some queries, you can ask.
Dear participants, if you have any queries, then you can unmute yourself and ask your queries. Or you can write your question in chat box also. Sir, there is one question. How can we decide which type of fluid, cooling fluid is required for the cutting process? How can we decide that? How can we choose that?
That's a nice question. See, there is a chart for that is metal cutting working application. That is for machining low carbon steel, which grade to be applied. Even Indian Oil Corporation has that chart. It is readily available it is openly available in internet. For ductile materials, ductile steels, what kind of what grade of this oil should be used? That is, the brand name is Servocut. Servocut is the oil machining cutting fluid. That is all about manufacturing. That is mineral-based oils. And for grinding, which Servocut grade to be used. That is all about mineral-based. And for vegetable-based, currently, in my knowledge, in our nation, we don't have a proper brand, but European Union and this United States are using Ecocut oil. That is a brand, Ecocut. So even Ecocut has various brands. They have given some recommendations. So for machining, for this type of machining, you use this grade. For this type of machining, you use for machining high carbon steel or brittle steel, you use this type of cutting fluids like that. There are recommendations. Yes.
Okay, sir.
Is it clear?
Yes, sir. Yes, sir.
Yes. Thank you.
Anyone have any query? Then please ask your query. You can unmute yourself and ask a question.
Good afternoon, sir.
Yes.
Yes.
Good afternoon.
Yes, sir. So, what about metals that change the color when they are under high temperatures, like titanium and other stuff? What will be used for such cases?
So you are asking about titanium machining.
Yes, sir.
Titanium. Some might say some that is metals are mentioned as difficult to cut metals, and titanium is one among that. So
Yes, sir.
one in steel is chromium-based steels. It is also difficult to cut. See, titanium machining is still a challenging one. So you are asking about the color change. Am I right?
Yes, sir. Not titanium specifically, but some metals do have that property, right? That they change the color under temperatures in certain conditions.
Yeah. In titanium machining, in titanium, any type of titanium alloy machining. So I am telling about dry cutting. Dry cutting, you can see fire sparks from that is the machining zone. Fire sparks. I mean in even in steel or aluminum, you can't see that continuous fires that is emits from high generation of that is heat, and metal oxidation happens in that titanium based alloys. See,
Yes, sir.
that highly affects the quality of machine surface. So the solution is applying the recommended cutting fluid in case of titanium machining. And titanium machining is currently a emerging research area. Yes.
Okay, sir. I understand.
Anyone more? Do anyone have any query? Please. Okay, I think there is no query more. So, dear participants, feedback link is available in chat box. So please fill the feedback form, and you will get the participant certificate on your mail ID. And now I thanks on behalf of Department Mechanical Engineering, Medicaps University Indore, to Dr. Milan to spare his time and share his knowledge. And really, sir, you are giving the valuable things like for sustainable development and different types of cutting fluids and machines. So these are very valuable for us, and I thank you to share your time with us. And
Thank you, sir.
yes, sir. Thank you, sir.
So I have put my contact, so you can be student participants or all the participants can be in touch with me?
Yes, yes, sir. Students can take the screenshot or write the number of sir. Their mail ID and WhatsApp number is there, so you can take it and you can get the contact with him anytime when you are required. A small token of gratitude from our side, Dr. Milan.
Sir?
Sir, just a small token of gratitude to you. I am sharing this.
Thank you. Thank you, sir.
Yes, yes, sir. Thank you, sir. Thank you very much for joining us and sharing your knowledge as a research speaker.
Thank you for creating me a space for delivering a lecture.
Yes, sir.